Hello everyone, welcome back to my YouTube channel Unfog with Dr. Athar Parveen. If you are new to my channel, please do subscribe to my channel, and if you are a regular viewer of my channel, then please like the video if you like it and also share it with your contacts and friends and HSTR aspirants and TET aspirants and all of them. And please do watch this lecture fully. Don't watch little bit portions. Please watch the full lecture. Have patience, then only you will gain knowledge and you will also come to know what type of questions will be asked from this topic. Now coming to this lecture, I am going to discuss all about lasers based on your HSTR, TET, CRISE and KV syllabus. In our previous video, the first video of this lesson, we discussed electromagnetic radiation, their examples, properties and uses. And also we discussed upon the electromagnetic spectrum in the first video. In the second lecture, we discussed all about the photoelectric effect, the experimental facts and Einstein's explanation about photoelectric effect and applications of photoelectric effect. If you have not watched those two lectures, please watch them. I will give the link in the description. It is better to watch these video lectures in order. First watch those two previous lectures, then you watch this present lecture. In this lecture, we are going to talk all about lasers, meaning of lasers, how they are produced, and what are the properties and uses of laser. If you have attended my previous class, you all will be knowing that there were many applications of photoelectric effect. One very important application about which I didn't talk in previous video is laser. The same phenomenon which occurred in photoelectric effect also leads to laser. Now what is laser? It is actually an abbreviation for the light amplification by stimulated emission of radiation. Here the name itself explains what is laser. It is the amplification of light which is happening due to stimulated emission of radiation or stimulated emission of photons. If I want to define this laser, it is a device or it is a tool by which an intense, monochromatic, parallel and highly coherent radiation can be obtained. A laser beam becomes very special because it has this following properties. It is monochromatic, it is highly directional, it is highly coherent and it has a very large intensity. Monochromatic means the laser beam, it has only one single wavelength. For example, this is a green beam of laser. This is unlike the ordinary light. In ordinary light, we have the spectrum, right? The WIBGOIR. We have many colors. We have many different wavelengths in that light. But this is not the way how it is in the laser. In laser, it can be of only one color on one wavelength. That's why we use this word monochromatic. Next important property of a laser beam is that it is highly directional. That means it will have one focused direction. It is not like ordinary light which can be scattered. Okay, this is also one very special property of laser. Then the third property is that it is highly coherent. Coherence means, see, actually these are the waves which are incoherent. Incoherent means their phase is different. They have different phase, they have different wavelengths. If you put together, if you superimpose all those waves together, you will not get one wave. You will get different waves. But in coherent waves, you put all the waves together, you can see that there is only one wave. Because here amplitude will be same, the wavelength will be same, everything will be same, the phase will be same. Okay, so this is the speciality of laser beam, that it will always be coherent. And fourth important property of a laser is that it is having very high intensity. In fact, there is one of a laser which gives you intensity higher than that of the sun's intensity. Okay, so this is one important property of laser. Now let's talk about the basic principle of how the laser can be generated. It is just simple like the photoelectric effect I told you. It is the electron energy transition. Electrons will transit from one energy level to another energy level. Actually, what was happening in photoelectric effect? In photoelectric effect, the electrons from the metal surface, they absorbed the energy from the incident photons and then they were ejected, right? They threw themselves out of the metal surface with that energy. After they absorbed the energy of the photon, they came out of the metal surface, isn't it? Now what happens in an atom? Usually in an atom, the electron jumps from the ground state to the higher energy state. Now when it jumps from the ground state to the higher energy state, it will need some energy, right? So that will happen when a energy is given to that atom. The electron will take that energy. For example, if you are focusing one photon on that electron will absorb energy and it will jump to the next energy level, the higher energy level. But then can it stay there for much time? No, it can't stay there for much time. So what it will do again? Again from the excited energy level, the electron will come back to the lower energy level and it will try to come to the ground state. At that time what it will do, it has gained some energy from the incident rays, right? It has gained some energy from the photons. That energy it will give back. Here the opposite thing happens. Here electron comes back from the excited state to the ground state. Okay, the both are transitions, but in the second procedure where the electron is coming from the higher energy level to the lower energy level, this process here, this helps in generation of laser. We will talk about this more. Now photoelectric effect is a stimulated emission, right? Why? Because the photons which are falling on the metal surface, they are stimulating the electrons to get ejected. Okay, so this stimulated emission, which is an example of the photoelectric effect, this was actually postulated by Einstein, right? In 1917 only. We talked about this in the previous lecture in the photoelectric effect. But actually Einstein, he told all this based on a theory. He was a theoretician. But again later in 1960, a person named Maimon, he worked on this principle and he developed a laser. That laser was a solid state laser and it was made of ruby. That's why it was called as a solid state ruby laser. Ruby is actually crystal. Crystal means solid state. Okay. Then next year in 1961, one gas laser was also developed by Ali Jawan and others in the Bell Lab. This was a helium neon laser. I am giving you these points because they may ask any question from anywhere, right? But I am sure that they will not ask very tough questions, nor will they be very easy. They will ask you moderate questions. So we will focus more on the moderate part. Okay. Now as I told you, the electron transition can be in two types. In two ways it can happen. The first is that the electron can take energy from the incident photon and it can jump from ground state to higher energy level. There what it is doing, the electron is absorbing the energy from the photon and it is using that energy to go to the higher energy level. Now what is the second way? The second way is that the electron from the excited state can come back to the ground state. At that time what it will do? It will give the photon which was there with it. It will give back the energy which was there. This is known as emission. It is emitting the light, right? This is known as emission. And this is happening spontaneously because you are not triggering it. The electron is coming back from the excited state because it cannot stay there much. It is not its home. Its home is ground state. So it wants to come back. So as soon as it gets excited from ground state to the higher energy level, immediately it wants to come back. It will come back also. It will give the energy back. It is emitting the energy back. So this is known as spontaneous emission. The first way was the absorption where electron went from ground state to the higher energy level. The second way is the spontaneous emission where electron will come back to its ground state. There is one more type of emission which will happen, that is known as stimulated emission. In this emission, electron may not have much urgency to come back in the ground state. But if one photon is given to that electron or if energy is given to that electron, then that electron will get stimulated and it will come back. And this time it will give two photons. One photon which was already there with it and one photon which is being given to stimulate that electron. It will release those two photons. It will release or it will emit those two energies back. Okay. So this is known as stimulated emission. And in laser, the third way is followed. or this is the procedure or the principle of generation of laser. The light amplification by stimulated emission of radiation. Here we have been stimulating the electron by giving the photon. This electron is already in the excited state. So it will come back in the ground state by giving you certain radiation. That radiation is only your laser. Okay. So I will give a short summary now. There are three types of processes in which the electron transition can happen. One is absorption, the other is the emission, but emission is of two types. One is the spontaneous emission and the other is the stimulated emission. Now we are worried only about the stimulated emission now, because stimulated emission is the one in which laser can be generated. Now this is the actual scenario, right? In an atom, the electrons are distributed in energy levels in this manner, right? In the ground state or the lower energy state, which I call as E1 here, many electrons are there. Then in E2, the higher energy state, little less will be there. And in the most higher energy level, little more less electrons will be there. This is how electrons are distributed in an atom also, right? So this is our actual scenario which is happening. Here usually number of atoms in the lower energy state, it will be more than the number of atoms in the excited state. Now here we are giving photons, right? But if you want the electrons to give the photons back, or if you want the electrons to emit energy, what should be happening? The electrons in the higher energy level should be more, right? Here to emit photons, number of atoms in the highest state must be greater than the number of atoms in the lower energy state. This is what the scenario should be there, right? Because we want the energy from the electrons. Or in other words, if I want to tell, population of atoms in higher energy state will be greater than population of atoms in lower energy state in that scenario. This scenario is known as population inversion. The process of making the population of atoms in higher energy state more than that of the lower energy state is known as population inversion. And the method by which population inversion is obtained is called optical pumping. That means you are pumping the electrons to the higher energy level, right? You are giving them photons, and that energy, the electrons will absorb that energy and they are triggered to go in the higher energy level. You are pumping them by force. That's why this is known as optical pumping. Actually, population inversion, it is difficult to achieve because that is not the ordinary situation, right? But if you want to achieve it, what you should do? If the higher energy state is short-lived, means actually see, electron doesn't want to live in the higher energy level, right? It wants to come back, isn't it? So the higher energy state, it is short-lived. That is, if the atom will come immediately, it will come quickly to the ground state by emitting a photon, then still you cannot at all achieve population inversion. Here metastable states come into picture. Actually, metastable states, they are one type of excited states, but they are not higher level energy levels, nor they are ground state level. It is intermediate, it is in between. It is the place where electron would like to stay for little while. Relatively long time it can stay than the excited state. How much time it is? It is 10 raised to minus 3 seconds. Not more than that. This 10 raised to minus 3 seconds only we will have to utilize so that we can generate the energy or we can generate the laser beam. And this is happening before spontaneous emission occurs. Okay. If atoms can be pumped into this metastable state fast enough, then you can achieve the population inversion. Once you achieve the population inversion, then you can have this optical pumping. Okay. Now we have many types of lasers actually, but for us important are these 3-4, actually only 3: solid state lasers, gas lasers and liquid dye lasers. Among these also only 3 lasers are very important. In fact 2 lasers are very important. One is ruby laser, which is a solid state laser. The other one is a helium neon laser, which is a gas laser. And third, one more laser is there. It is a neodymium doped yttrium aluminium garnet laser. This we are not going to study, but it is having one speciality. We will talk about that speciality. This ruby laser and helium neon laser, we can see the working, construction and their specialities, their properties also. Because questions comes only from ruby laser and helium neon laser only. Rest all we will not discuss because we don't want to waste time in discussing things which will not be asked in the exam. In ruby laser, the process which is used for generation of laser is optical pumping. Okay, this is the working and this is the construction, you can say. Actually construction we don't need, so I have not put here. Working I will explain you. Here I have given you the energy level diagram here. See, in the E0, the ground state, see, imagine some electrons are there, then you give some energy. That energy is around 400 nanometers. That energy will be absorbed by the electrons and they will go to excited state, maybe E1 and then maybe E2. Then they want to come back to the ground state, right? We will not allow them to come back to the ground state. We have metastable states, right? So those electrons, they will go to metastable states. Now these electrons, they have this energy which they have absorbed from the photons, right? They will not radiate that energy right now. They will go to the metastable state. Once they are there in the metastable states, after that when they want to come back to the ground state, then only here optical pumping will happen. In metastable state you can do optical pumping, and then when transition occurs from this E state to the E0 state, then you can find that a laser is generated. That laser will be of the wavelength 694.3 nanometer. Okay, here one is the ground state, that is one level. Second level is the higher state, E2. Then the third level is the metastable state, right? That's why ruby laser is also known as a 3-level laser. Okay, I have not gone much into deeper because I don't want to trouble you. Whatever I am talking is very much important. Those you can note down. Here one more important point is that this ruby crystal which is used in this laser, no, it contains chromium ions, Cr3+. These are the ones which absorb photons of visible light of 400 nanometer, or if 500 nanometer is given, that they will absorb, and then that electrons will jump from ground state to the excited state. Okay. Now don't worry about this construction and all that. I will give you important questions which will be asked from ruby laser. Now you have the base idea of this ruby laser, right? Now you can answer few important questions. Believe me, only questions from these list will be asked. Okay, these are the most expected questions. The question is, in a ruby laser, the color of laser light is due to which atom? Only chromium is there in that, right? So chromium will be the right answer. Next question is, in ruby laser, the pumping method used to achieve population inversion is. This is actually your 2015 HSTR question paper question. Okay, here in ruby laser, optical pumping is happening. Because of optical pumping only, we can achieve population inversion. The next question is, which of the following is a 3-level laser? I told you, right? That is ruby laser. Next question. Laser is produced by, they have given you 4 options: graphite, ruby, diamond, emerald. We know it is ruby, right? The ruby crystal. Then the next question is, the lifetime of metastable state in a ruby laser is. It is 10 raised to minus 3 seconds. I told you, right? In metastable state, the electrons can stay till up to about 10 raised to minus 3 seconds. Next question. The state of population inversion necessary for laser action with the occurrence of stimulated emission used in solid state lasers is by. It should be optical pumping. Now let's talk about helium neon laser. It is a gas laser, right? Ruby laser was a solid state laser. This helium neon laser is a gas laser. In an excited helium atom, one can have inelastic collision with a neon atom in the ground state. At this time, no, this neon atom, it will reach the metastable state, and then again the helium atom will come back to the ground state. Basically, helium and neon collision will lead to production of laser beam here. I have this electronic transition also. Here now, don't worry about the energy and all. Just you have to remember that the helium neon laser will emit the wavelength of 632.8 nanometer. This is the important value which you have to remember here. Here no, there is one glass tube. In this glass tube, 90% of helium gas and 10% of neon gas are mixed together. Then an electrical discharge will be established here in this tube. There will be mirrors, they will be bonded at the ends of the discharge tube. Now if you change the mirrors, no, then you can have different color laser beams or different wavelength laser beams. For example, you can have green laser beam which will be of 543.5 nanometer, yellow, orange with a different wavelengths. Okay, and here optical pumping is not happening. Okay, here electronic transition is happening because of electrical signals. See, we have this cathode and anode, right? We didn't have any cathode and anode there in solid state ruby laser. Okay, and here main important thing is that after the collision between helium and neon atoms, the gas atoms, then only the stimulated emission will occur. Okay, so these are few questions based on helium neon laser. First question is, which of the following is a 4-level laser? Here you can see that there are 4 levels. First is that by optical pumping, electrons will go to this higher energy level. Then one stimulated emission will happen. After that again spontaneous transition will happen. Here you can see that there are 4 energy levels. That's why helium neon laser is also known as 4-level laser. There are 2 important points which I have to mention here. One is that this helium neon laser, it will give us continuous beam of laser. Okay, whereas this neodymium aluminium garnet laser is there. Now it was a solid state laser. I told you that I will tell you only one point about this, right? This will give laser in pulses. So this question can be asked. These 2 points you remember. Helium neon laser will give continuous laser beam, and neodymium yttrium aluminium garnet laser will give you pulses. It will not give you continuous laser beam. Okay, next question is, helium neon laser is a type of course it is a gas laser. Next question, the helium neon laser operates at a wavelength of, yes, it is 632 nanometer. You have to remember this value. Now let's talk about uses of laser. Laser has many uses actually. See, in medical science, no, you can use laser in many ways actually. Without cutting, without flow of blood and all that, you can use that laser, isn't it? Your skin can be treated, then cancer can be treated, then nowadays to laparoscopy, that surgery, so many things are happening because of laser, right? That's why this laser is known as non-material knife. Okay, because it can produce very narrow beam with high intensity. That's why it is used everywhere. It is used even in detaching the retina in your eye. Okay, next, in communications, it can travel for long distances, right? Without spreading, it can travel for long distances. That's why it is used in communications, in radio communications and for signals and all that. Then it is used in technology. Technology means to cut the hard materials. Even diamond can be cut with laser. Okay, then also they will put many layers of clothes together and then they will cut at a time with this laser. That's why it is known as non-material knife, I told you, right? Next use it is in meteorology. It is used for gathering this weather information with the help of radar. Radar is actually, it is an instrument. It is based on the properties of laser only. Then they can also measure long distance because it can travel long distances, right? So they can even measure the distance of moon from earth by using this laser device. Then it is used in war field to detect and destroy the rockets of enemy. And then also you can observe the enemies at night also using this laser. And of course it is used in space sciences to control rockets, spaceships and satellites. And one very important application of laser and a famous application is a holography. Holography means you can see 3-dimensional pictures. You tilt the picture, sometimes it will appear, sometimes it will disappear. This is done by laser only. Okay, so these were the uses of laser. These are the disadvantages. Once it's better, we have the glance of disadvantages also. There are few disadvantages of laser. First is that it is dangerous to our atmosphere and it is dangerous to our health. And laser printers are found, they are in the market, but they are very costly. So people prefer other printers only nowadays. The budget issue is there. Then this lasers, it is harmful for ozone. That we have to be careful. And then these laser particles, they are known to emit the particles that can cause the respiratory diseases. So if one is working in the laboratory using lasers, he has to or she has to take precautions to save themselves from these disadvantages. Now I have few more general questions based on lasers. I will give you those also. First is that which of the following can be used for the generation of laser pulse? I told you, right, that is NDYAG laser, neodymium doped yttrium aluminium garnet laser. Next question is, these are used for bloodless surgery. It is laser. Next question, laser is based on the phenomenon of? Yes, it is stimulated emission. Now I have this question for you all. You have to give me the option. Just write the option number in the comment section. Okay. Let me know how much you have focused on my class. Okay. Okay, that's all for this lecture. And with this lecture, I finish your chapter electromagnetic radiation, and I have given you enough of expected MCQs also. It will be helpful for HSTR people, CRISE people, KV people, TET people, all the teacher recruitment people. Okay, all the aspirants who are preparing for this teacher recruitment exams. Okay, I hope this lecture will help you, and that's it. Do like, share and subscribe to my channel. All the best. Keep working hard. Bye.